So today we're going to be multiplying matrices together. So yesterday we were multiplying a matrix by a number. Today we're multiplying a matrix by a matrix. So first thing we want to look at, it says a matrix is a rectangular array of numbers. You usually display the array with brackets. So we've been dealing with matrices for the last two sections, so we know that we put brackets around our matrix. And the dimensions of a matrix are the numbers of rows and columns in the array. So always when we write our dimension, we say row by column. So the row comes first. So rows are the ones that are straight across. So here we have 2 rows. And columns are the ones that are up and down. So we have 1, 2, 3 columns. So we would say this is a 2 by 3 matrix. So it's always rows first. And think of rows as in like rows of a movie theater. Like you go down the row. So those are the ones that are straight across. And columns are the ones that are up and down. So row by column. So in order to multiply a matrix, we need, if we have a matrix that, I'll give numbers as examples. So if we have a matrix that is a 2 by 3, and matrix B is a 3 by 2, we need the inside numbers here to be the same in order to multiply them. If they're not the same, then it's undefined. We can't multiply them. On to the next problem. So we need the inside ones to be the same, and then the outside ones are the dimensions of our new matrix. So this would be, our new matrix would be a 2 times 2 matrix. So always need the inside ones to be the same. The outside ones are the dimensions of our multiplied answer.
Can we still multiply the outside one if they're not the same?
Right, if the outside ones were not the same, so let's say this was 4 here, then our matrix would be a 2 by 4, and we can still multiply. So we only need the inside ones to be the same. And the outside ones just tell us our answer. It tells us the size of our answer, not our answer exactly. So let's look at our first example. We need to determine whether each matrix product is defined. If so, state the dimensions of the product. So first thing we need to look and see, are the inside dimensions the same? Yeah. Yes, so we can multiply these. So next we want to look at the outside dimensions. And this tells us the size of our answer. So what would our size be? 3 by 2. Perfect. Yep, for these, this is our answer. So this would be like the size. If we had a matrix A and a matrix B, this would be the size of our answer. So this question asks to state the dimensions of the product, so the size of our answer. So our answer for this is 3 by 2. So yes, we can multiply it, and it would be a 3 by 2. Ready for the next one? All right, example 2. So we need to look at the inside ones. Are these the same? No. So can we multiply these two matrices together? No. Nope. So can't multiply. So we can say undefined. So since these are not the same, it's undefined. All right, example 3, let's look at part A. So can we multiply these matrices together? Yep, because this is a 6 and this is a 6. What is the size of our product? Awesome. It's the outside ones, which would be 4 by 2. Yep.
Oh, so the answer's only the outside one?
Yes. So this is the size of our product. So the size when we multiply them is going to be a 4 by 2. For these questions, this is just the answer. On the next slide, we're actually multiplying them. So we'll have like an actual matrix as our answer. All right, and 1b. Can we multiply these two together? Nope, because our inside ones are not the same. So what would our answer be here? Undefined. All right, so next we are going to actually multiply our matrices together. Yes. Yes. All right, so we're multiplying x and y together. So it says find x times y. First thing we need to do is state our dimensions. So how many rows do we have for x? And how many columns? So this is a 2 by 2. What about y? How many rows? And how many columns? 2. Can we multiply these two together? Yep, because our insides are the same. And then what are the dimensions of our answer? So our answer is going to be a 2 by 2. So now we actually need to multiply it out and find our answer. So I'm just going to rewrite x and y here. So I have 6, negative 3, negative 10, negative 2, times negative 5, negative 4, 3, and 3. So our answer is going to be a 2 by 2 matrix. Now here comes, I don't want to say the tricky part, but the part that you got to think about. So to multiply matrices, what we do is we take the first row of the first one and the first column of the second. And that's going to tell us what goes in our first row, first column in our answer here. So that's going to tell us what goes here. Now what we do is we take the first number and multiply them together. So we have 6 times negative 5. And then we add the second number and multiply those two together. So we add negative 3 times 3. So that's the first row, first column, and it goes in the first row, first column spot. Next, we're going to multiply the first row and the second column. So this is going to go in the first row, second column spot. So we do it again. So we take one number at a time. We multiply the first number with the first number. So 6 times negative 4. And then we add the second number and the second number. So plus negative 3 times 3. Which we're actually going to do the math here in the next step. I just want to write it all out first. So now we're going to, yes.
Are you always going to add?
Yeah. So we multiply the first and the first, then add the multiplication of the second and the second. So that's why we multiply these two, add the multiplication of the next two. So now we're going to move on to the second row. So we're looking at the second row, first column. And that's going to go in the second row, first column here. So we take the first number and the first number. So 10 times negative 5, negative 10 times negative 5. And then we add the second number times the second number. So negative 2 times 3. So now we do it again. We have our second row, second column, which is going to go in our second row, second column here. So we multiply the first number times the first number. So that would be negative 10 times negative 4. Plus the second number times the second number, which is negative 2 times 3. Now we just need to do all the math that's in here. So we're just going to take it we can call it one color at a time. So it's going to make a 2 by 2 matrix. So let's look at the black one first, up top in the left. We have 6 times negative 5, which is what? So negative 30 plus, what's negative 3 times 3? Negative 9. So what is negative 30 plus negative 9? Negative 39. So now we move on to the next one, the red one, the top right. So it's 6 times negative 4. Negative 24. Plus, what's negative 3 times 3? What's negative 24 plus negative 9? Negative 33. All right, on to the next. We have negative 10 times negative 5. 50. Plus, what's negative 2 times 3? So what's 50 plus negative 6? 44. And then our last one's the green one. What's negative 10 times negative 4? 40. And then plus, what's negative 2 times 3? Negative 6. What's 40 plus negative 6? 34. So then this is our answer. And we always got to check and see. We said that this was going to be a 2 by 2. Is this a 2 by 2? Yep. So this is our answer. Perfect. The dimensions are going to be 4 by 1. So it's going to have 4 rows and 1 column. So it's going to look like this. We have a tall, skinny one as our answer. Because we have 4 rows and 1 column. Alright, so now let's multiply it out. So I'm just going to rewrite it down here. We have 4, 7, 3, 8, 9, 1, 10, 5, 3, and 3, 3, and 6, times 7, 4, and 2. Bless you. All right. So we're going to start by multiplying the first row times the first column. So we do it one pair at a time. So 4 times 7. Then plus the second number times the second number. So 7 times 4. And then plus the third number times the third number, so 3 times 2. So in the first one, you're moving with the rows. The second one, you're moving with the columns. So now we move on to the second row. First column. So our second row, first column is going to be in the second row, first column in our answer. So we go one number at a time. The first times the first, so 8 times 7. Then the second times the second, so 9 times 4. Then the third times the third, so 1 times 2. Now we move on to the third row, first column, and that's going to go in the third row, first column in our answer. So what are we going to multiply first? 10 and 7. What comes next? This is a 5, right? Yep. 5 times 4, perfect. So the second times the second, 5 times 4, then plus the third times the third, so 3 times 2. All right, now we can move on to the fourth row, first column, which is going to go in our fourth row, first column in our answer. So what do we multiply first? 3 times 7. What comes next? So then plus the second times the second, which is 3 times 4. And then plus the third times the third, which is what? 6 times 2. Now we actually have to multiply all of these out. Multiply and add them all out. So what is 4 times 7? 28. And then 4 times 7 again is 28. And 3 times 2? 6. So what's 28 plus 28 plus 6? $62. So that's going to go in our first row, first column up here. 62. What's 8 times 7? 56. What's 9 times 4? 36. And what's 1 times 2? 2. So what's 56 plus 36 plus 2? 94. So 94 comes next. Alright, next, what's 10 times 7? 70. What is 5 times 4? 20. And what's 3 times 2? 6. So what's 70 plus 20 plus 6? Awesome, 96. And then lastly, what's 3 times 7? And 3 times 4? 12. And 6 times 2? 12. So what's 21 plus 12 plus 12? 45. Perfect. So is our answer that we got here a 4 by 1? Yep. So we did it right. We're all good. This is our answer. So first thing we need to do is check our dimensions. How many rows and how many columns do we have in the first one?
2 by 1.
Perfect. 2 rows, 1 column, so it's a 2 by 1. How many rows and how many columns do we have in the next?
1 by 1.
It is a 1 by, how many columns do we have?
1. 2.
We have 1, 2, 3. So 1 by 3. So can we multiply these two together? Yeah, because the insides are the same. And what is going to be the dimensions of our answer? a 2 by 3. So we're going to have 2 rows and 3 columns in our answer. Alright, so let's multiply these out. I'm going to make this big because I know we're going to have 2 rows and 3 columns of map. So let's start with our first row, first column. First row, first column would just be 1. Oops, whoa, I did that backwards. First row, first column. So remember, in the first one, we only look and move in rows. The second one, we move in columns. So first row, first column, here we only are doing -9 times -1. So what's -9 times -1? +9. Next, we have the first row, second column. So that's going to go in our first row, second column right here. So what is -9 times -10? 90. And then we have our first row, third column. So what's -9 times 1? -9. So now we move on to our second row. So we have the second row, first column. So 6 times -1. -6. Then we have 6 times -10. So second row, second column would be -60. Awesome. And then lastly we have second row, third column, which would be what? 6. So just 6 times 1, which is 6. Does this make a little bit more sense?
Yeah.
So you just have to be careful. And remember, in your first one that you're multiplying, you move in the rows. You go 1 row at a time. In the second one, you move in columns. So you go 1 column at a time. Any questions? Alright, let's go ahead and open up the homework and we'll do one together. Alright, let's look at number 1. What's the first thing we have to do? State our dimension. So how many rows do we have in the first one? 1 row and 3 columns, so it's a 1 by 3. What about the second one? How many rows do we have? 3 rows and how many columns? 2. Can we multiply these together? Yep, because they're the insides are the same. And what is our solution going to be? A 1 by 2. So our answer is going to have 1 row and 2 columns. So we're going to have a number here and a number here. So it's going to be a little guy. So let's multiply this out. So even though our answer is going to be little, we have lots of math that's going to go on, so I'm just going to make this box big. Actually, I could probably make it like this. So for the first matrix we have here, what are we looking at, the rows or columns? We move in rows in the first one, and in the second one, do we look at the rows or the columns? Columns. So we're going to take the first row and the first column. We can only multiply one group at a time. So we have 1 times -3. What's 1 times -3? -3. I'm going to leave it as 1 times -3 just so we can see that that's what we're multiplying. And then plus negative 3 times 4. So now we move on to the second number, negative 3 times 4. Yep, negative 12. And then move on to the third number, so this will be plus negative 6 times negative 1.
Miss Garber,
Yep.
do we have to show that work on the homework?
No, if you want to say that this is negative 3, negative 12, and 6. You don't have to show this step, but you got to show your work because these require work. Alright, let's go to now the first row, second column. So we have our first row, second column. What do we do first? Awesome. 1 times negative 6 plus, what comes next? Negative 3 times 0. What comes next? Perfect. Negative 6 times negative 4. Alright, so we multiplied these out already. So we got negative 3, negative 12, and 6. So what's negative 3 plus negative 12?
Negative 15.
Negative 15, and then negative 15 plus 6. Negative 9. So in our first space, we have negative 9. Now let's look at our second one. What's 1 times negative 6? Negative 6. What's 3 times 0? And what is negative 6 times negative 4? Positive 24. So what is negative 6 plus 0 plus 24? $18. Awesome. So in our second space here, we have 18. So is our answer that we got a 1 by 2? Yep. So we did our work right. So this is our answer.